being recorded.
Okay, chemistry. I'm going to do a couple of the problems on stoichiometry homework number 1. Okay, number 1, you got to balance that equation. I don't think I'm going to do number 1. I'm going to let you try number 1 by yourself. Go ahead and balance the equation and then find, well, maybe I'll do it. I don't know. All right, let's start out with number 1. C3H8 plus O2, CO2 plus H2O. We got to go ahead and balance this first. How in the world do we balance it? Well, we got, we're going to have to put a 3 here to get 3 carbons, and that's going to give us, and then we got 8 hydrogen, so we're going to have to put a 4 here to get 8 hydrogen, and that gives us 6 plus 4, that gives us 10 oxygen, so we got to put a 5 there. So now it's balanced. So I'm going to set it up for you, and you are going to finish it. What you're given, you are given 6.40 moles of C3H8. So that's what we put on the bottom. And what are we looking for? We're looking for moles of CO2. So you fill in those numbers and come up with the right answer. Okay, number 2, it's already balanced for you. 5C plus 2 SO2 gives you CS2 plus 4CO. Okay, how many moles of CS2 forms from 2.7 moles of when 2.7 moles of C reacts? Okay, this is A. 2.7, what you're given, moles of C, and you're looking for moles of CS2. So you fill that in and come up with the right answer, and you do B by yourself. All right, let's look at number 3. Lithium and oxygen, remember oxygen is always O2, react explosively to form lithium oxide. If you look at lithium and oxygen on your periodic table, lithium is a +1, but oxygen is a -2. So we got to do this, and lithium oxide is Li2O. And that's not balanced. So we got to go ahead and balance this. We got to put a 2 here. So we have 2 oxygens, which means that gives us 4 lithium. So we got to put a 4 there to get 4 lithium. Now it's all balanced. Now let's set up the equation. It says, then calculate how many moles of lithium oxide will form if 1.68 moles of lithium reacted with the oxygen. So we're going to put moles of lithium, and we're looking for moles of lithium oxide on the top. So you fill that in and come up with the right answer. That's moles to moles. Okay, section 2, moles to mass. Write a balanced equation for the double replacement reaction between barium acetate and potassium phosphate. So we got to find barium and acetate. So barium has barium. Where is barium? There's boron, beryllium. Barium has a +2. And acetate, if you look on your, your polyatomic ions, it's this really long one, C2H3O2, and it has a -1 charge. So when we make barium acetate, we're going to have BaC2H3O2, 2. Okay, there's barium acetate, and it is going with potassium phosphate. So we got potassium, which is K, and phosphate, which is PO4, which is a -3, and potassium is a +1. So that becomes K3PO4. Okay, so those are going to go together to, and it tells us that it is a double replacement. That means now barium is going to go with PO4, and potassium is going to go with the C2H3O2. So now we've got to do barium, which is a +2, and PO4, which is a -3. So that's going to become Ba3PO42. And now potassium, which is a +1, goes with C2H3O2, which is a -1. So that is KC2H3O2. Look, you got to use all your things that we've done in all the chapters in order to do these problems. So here's our problem right now, but now we've got to balance it. So because the acetate stays the same, we can just think of it as 1. So let's see what we're going to do here. We've got 2, acetate can stay the same, and phosphate. Here we have 2 phosphates, so we're going to have to put a 2 here to have 2 phosphates, which gives us 6 potassium. So we got to put a 6 here, which means we're going to have to put a 3 here, and now everything is balanced. So now we can actually do the problem. Write what you're given. 4.36 moles of potassium phosphate. Potassium phosphate. And it's already moles, so those go on the bottom. We don't have to change it to moles. And we're looking for grams of barium phosphate. So we first have to change it to moles of barium phosphate. And then we change the moles to grams. Okay, these numbers right here come from our balanced equation. Moles is 1. This number comes from the periodic table. You got to look all that up and then find the answer. Okay, number 5, A and B, I'm going to let you do by yourself. You have the balanced equation all there. All you have to do is have the conversions. There will be 3 of them, just like this. It's what you're given. You're going to do moles to moles, and then in the end is going to be grams. That's number 5, A and B. I want you to do that one. Number 6, mass to mole. I'll do A, I'll set up A, and then you can do B. You can finish A. CaC2 plus 2H2O, C2H2 plus CaOH2. Okay, it's all balanced. We don't have to worry about that. Let's get a different color here. Let's start what we're given. 32 grams of CaC2, which means we first have to change it to moles, because you always change it to moles first if you don't have that. Then we're going to change the moles to the moles of the unknown, which is calcium hydroxide. And it's asking you for moles of calcium hydroxide, so then we're done. Because this cancels with this cancels with this, and this is what we're looking for. This number comes from the periodic table. These numbers come from your balanced equation, and then you can find your answer. And then go ahead and do part B by yourself. Okay, this is the homework for the first section.